So we've looked at limits, we've learned how to find limits, we've looked at continuity. And before we jump into average rate of change or rates of change, and looking at actually even instantaneous rates of change, we're just going to kind of warm up what we've been doing. So we have a piecewise function here, and it's f of x. First equation is x plus 1 if x is less than 3. Second equation would be 2x minus 2 if x is between and including 3 and 5. And then the last equation is 4x plus 1 if x is bigger than 5. So first question wants us to find the limit as x is approaching 3 of f of x. If you look at the piecewise function and you notice where 3 falls, well, notice that 3 is actually an inbound of an inequality. So for numbers that are smaller than 3, we would use this first equation. And if numbers were bigger than 3, then we would use the second equation. And so remember, when we're looking at limits, we need to see that the left and the right-hand side are going to the same thing. So let's look at the limit here as x is approaching 3 on the left. And so again, those are values which are smaller than 3, which tells us to use this first equation. So I'm just going to plug in here x plus 1. And so we would do direct substitution. So go in here and plug in 3 wherever you see an x, and we get 3 plus 1, which gives us back 4. We also want to see what's happening on the right-hand side of 3. And so we would use our second equation there. And so let's look at the limit as x is approaching 3 on the right-hand side of that of 3. That equation, we would use 2x minus 2. Again, we would go in and do direct substitution and plug in 3 wherever we see an x. We have 2 times 3 minus 2. So this gives us 6 minus 2, which is also 4. And so since these are the same, we know that the limit as x approaches 3 of f of x does exist, and it would be equal to 4. So part B asks that you find the limit as x is approaching 5 of f of x. So again, I would look up at my piecewise function and see where 5 lies, which equation I would use. If it is a bound, one of the bounds of the inequality, which again, in this case it is, we need to make sure that the left-hand side and the right-hand side are the same. And so let's look at the limit as x is approaching 5 on the left. So those are values of x that are smaller than 5. And we're always using the equation closest or piece of the graph closest. So this would be using this 2x minus 2. So go in, do direct substitution. So we have 2, we see an x there. We're going to replace it with 5 minus 2. So we get 2 times 5 is 10 minus 2. This gives us back 8. So let's look at, again, what's happening when the limit is x is approaching 5, but this time on the right-hand side. And so if I look at that, those are values that are bigger than 5, which tells me to use this third equation, 4x plus 1. Do direct substitution, and we have 4 times 5 plus 1. 4 times 5 is 20 plus 1. So that gives us 21. These are not the same. So because they're not the same, we say that the limit does not exist. And they had one other question. So C, and C wanted us to find the limit as x approaches 6. Well, notice that 6 is not one of the end bounds of our inequality. And so we don't really have to worry about left-hand and right-hand side because each one of these equations are polynomials. So they're always continuous everywhere. The only thing we have to be worried about is this is a piecewise function. And so that it might not, the limit might not exist at these values where we're changing equations. But this one is just x is greater than, or going to 6. And so 6 is bigger than 5. That tells us that we're using the third equation. And the left hand and the right hand side would be using the same equation there. And again, we can just do direct substitution. And so we'd have 4 times 6 plus 1. Well, 4 times 6 is 24 plus 1 gives us back 25. So the limit does exist and it's 25. Questions on that?